So let's begin by discussing 2x2 systems. A 2x2 system has two equations with two unknown variables. The substitution and elimination methods can be used to solve a system. So this here would be an example of a 2x2 system. Our first equation is x minus 2y is equal to -7. And our second equation is 2x plus 3y is equal to 7. So we see in both equations we have two unknown variables, our x and y. So in our 2x2 systems chapter, we reviewed the substitution and elimination methods for finding the value of x and y in this system. In this chapter, we'll be using a process known as Cramer's rule to find x and y for a 2x2 and a 3x3 system. In order to do so, we must first review what a matrix is, specifically a coefficient matrix. A coefficient of a term is the number in front of the variable, and a matrix is a grid of numbers. A coefficient matrix is a matrix of the coefficients from the system. So here, our coefficients in this row here in this equation are 1 and -2. So in this matrix here, row 1, we have +1 and -2. The coefficients in our second equation are +2 in front of our x and +3 in front of our y. So those go in our coefficient matrix in the second row. And a matrix is denoted with brackets on both sides of the grid of numbers. So this would be an example of a coefficient matrix. We have a grid of numbers that represent the coefficients from the equations. Now, the determinant is a number that can be calculated from the coefficient matrix of the system and is denoted by two vertical lines. So throughout this chapter, instead of two brackets on the two sides of our grid of numbers, we'll have two straight lines such as these two here. And this is what we'll be using to show that we're calculating the determinant of this matrix. Now let's review some basics about a matrix, just so we're clear about the language that I'll be using throughout this chapter. Rows are represented by the letter R, are aligned horizontally, and are counted from top to bottom. So we start with row 1 at the top of our grid. As we make our way down, the next row is row 2. And as I stated, they go horizontally. So it's moving from left to right. Columns are denoted by the lowercase c and are aligned vertically and are counted from left to right. So we start all the way to the left on our grid. This is the first column, C1. This is the second column, C2. So 1 is in row 1, column 1. So this spot in our grid here can be represented with the expression R1C1, the first row, the first column. +2 beneath it. We are now moving from row 1 to row 2. So we have row 2, but we're in the same column. So that's column 1. So this spot in our grid can be represented by R2C1. -2 here, we're back in the first row. So this is R1. But now we've moved from column 1 to column 2. So this spot in our grid can be represented with R1C2. And +3 is in the second row in the second column, so it can be represented by R2C2. This will help make the steps that we're going to use for calculating a determinant a little bit clearer. Now, Cramer's rule can be used to find the solution, or the xy coordinate, of a 2x2 system, and the solution, xyz coordinate, of a 3x3 system. So we'll be using determinants for a 2x2 system, and then from those determinants, we'll calculate the x coordinate and the y coordinate for the solution in a 2x2 system. And then Cramer's rule can also be applied to 3x3 systems as well. And we'll use a set of determinants to calculate the x coordinate, the y coordinate, and the z coordinate of that solution. So we'll wind up talking about each of these things throughout the remainder of this chapter. So let's now move on to discussing 2x2 determinants. The determinant of a 2x2 system can be calculated with the following formula. So the determinant D is equal to, we have our coefficient matrix between our two vertical lines. And the formula is we take the number that is in the first row, column 1, and we multiply it times the number diagonally down to the right here. So we would be multiplying A times D. And then we subtract the product of the number that's in the second row and first column times the number up and to the right, which would be row 1, C2. So we wind up multiplying C times B, giving us AD, multiplying down to the right, minus CB, multiplying up to the right. So let's say we had 1, 2 in the first row and 3, 4 in the second row. We would have 1 times 4 minus 3 times 2. And then using this expression, we can then solve for D for this 2x2 system. Remember, these numbers represent the coefficients of a system, but we're just going to work with the matrix for now to practice solving for the determinant. So let's walk through an example from the start. We have a 2x2 matrix, and we're asked to find the determinant. We have 2, -1 in column 1, and 5, 3 in column 2. So step 1, multiply the numbers going down to the right, starting with R1, C1. The first row is furthest to the top. The first column is furthest to the left. So that would be positive 2 here. And we want to multiply the numbers 2 and 3, since we're going down to the right. So we have 2 times 3. And then the second step is to place a minus sign after the product from step 1. So we have 2 times 3 minus. And now step 3, we want to multiply the numbers going up to the right, starting with R2, C1. So the second row and the first column leads us to -1. And we want to multiply -1 and 5, since we're going up to the right. So we wind up with 2 times 3 minus -1 times 5. So now we can solve for D. 2 times 3 is equal to 6, minus -1 times 5 would be -5. 6 minus -5 is equivalent to 6 plus 5. So we see that D is equal to 6 plus 5, which means the determinant is equal to positive 11. So that is how you would find the determinant of a 2x2 matrix. Let's now have you try a few practice questions. Question number 1, find the determinant of this 2x2 matrix. Column 1, we have positive 1 and -1. Column 2, we have -2 and positive 3. Question number 2, column 1, we have positive 2 and -3. Column 2, we have positive 4 and -2. Question number 3, column 1, we have -1 and positive 3. Column 2, we have -3 and positive 5. And question number 4, column 1 is -3, positive 5. And column 2 is positive 4, -2. Pause the video, answer these questions, and then press play when you are ready to begin. Question number 1, step 1, multiply the numbers going down to the right, starting with row 1, column 1. So the first row is furthest to the top. The first column is furthest to the left. So row 1, column 1 is positive 1 here. And we want to multiply going down to the right. So we multiply positive 1 times positive 3. Now step 2, we want to place a minus sign after the product from step 1. And now step 3, we want to multiply the numbers going up to the right, starting with R2C1. So that would be negative 1. And if we're multiplying going up to the right, we multiply that times negative 2. So that gives us 1 times 3, which is positive 3, minus negative 1 times negative 2, which would be 2. So we see D is equal to 3 minus 2, which means the determinant for question number 1 is equal to positive 1. Question number 2. Step 1, multiply the numbers going down to the right, starting with row 1, column 1. So that means we're multiplying 2 times negative 2. And then step 2, we want to place a minus sign after the product from step 1. And now step 3, we want to multiply the numbers going up to the right, starting with the second row, column 1. So that would be negative 3. And if we're multiplying going up to the right, that means we're multiplying negative 3 times 4. So now we can solve for D, giving us 2 times negative 2, which is negative 4, minus negative 3 times 4 is negative 12. Negative 4 minus negative 12 is equivalent to negative 4 plus 12, and that would be positive 8. So the answer to question number 2 is the determinant is equal to positive 8. Let's now have a look at question number 3. Step 1, multiply the numbers going down to the right, starting with R1C1. So we multiply negative 1 times 5. And then step 2, we place a minus sign after the product from step 1. Then step 3, we multiply the numbers going up to the right, starting with R2C1, which would be positive 3. So if we go up to the right, we see that we want to multiply positive 3 times negative 3 here. And now step 4, we can solve for D. So we have negative 1 times 5, which is negative 5, minus 3 times negative 3 is negative 9. Negative 5 minus negative 9 is equivalent to negative 5 plus 9, and that would be equal to positive 4. So the answer to question number 3 is the determinant is equal to positive 4. So that is the answer to question number 3. Let's now have a look at question number 4. Step 1, multiply the numbers going down to the right, starting with row 1, column 1. So that would be negative 3. And if we're going down to the right, we want to multiply negative 3 times negative 2. And now we want to place a minus sign after the product from step 1. In step 3, we want to multiply the numbers going up to the right, starting with R2C1, second row, first column. So that would be positive 5. Going up to the right means we're multiplying 5 times 4. So now to solve for D, we have negative 3 times negative 2, which is positive 6, minus 5 times 4, which is 20. Showing us the determinant is equal to 6 minus 20, which would be negative 14.